Fish processing and preservation. Introduction. Fish is an excellent food for man, provides protein, fat, minerals, and vitamins. It is easily digestible due to low percentage of connective tissue. Fish flesh contains all the essential amino acids and also provides calcium, magnesium, potassium, sodium, iodine, phosphorus, and vitamins A, B, and D. However, fish is spoiled quickly due to high water content in its body and must be properly preserved so that it reaches the consumer in good condition. As we know that live fish carries a large number of bacteria on its body, gills, and in the gut. After the fish dies, the bacteria reproduce rapidly and attack various organs, causing deterioration of the fish. For a layman, a fresh fish can be easily recognized by the following features. The eyes are glistening and not opaque. Gills are of bright red color. The flesh is stiff and not soft and flabby. Smell of the slime is fishy and not foul. The vent is not protruding. When touched, fingerprints are not left on the body surface. Spoilage of fish. After catching the fish from the water, it cannot survive and quickly dies of suffocation. It remains in good condition for a few hours only, after which decomposition begins due to 1. Bacterial action, 2. Enzymatic action, and 3. Chemical action. Rigor mortis. After the fish is dead, it remains soft and fresh for 5 to 7 hours, after which the muscles become stiff. This stiffness or rigidity of the muscles is called rigor mortis and lasts for several hours, during which the fish is regarded as fresh and fit for human consumption after this decomposition of the fish starts. Causes of the spoilage of fish. Soon after rigor mortis is over, the fish undergoes deterioration rapidly and becomes alkaline, foul-smelling, and inedible. Fish are spoiled due to the action of bacteria which are present on the body, gills, and gut of the fish. Commonly occurring bacteria are Pseudomonas, Bacillus, Haemophilus, Myxobacterium, and Mycobacterium. Preservation of fish. Preservation of fish is necessary to prevent spoilage and to keep the fish fresh and fit of human consumption. Method employed for preservation should be such that there is minimum loss of flavor, taste, odor, and nutritive value of the fish. Various methods of preserving fish are A. Chilling with ice, B. Freezing, C. Freeze-drying and deep freezing, D. Sun-drying, E. Smoking, F. Salting, G. Brining, H. Pickling, I. Canning, J. Use of chemicals and radiation. Chilling. This is the simple method to prevent spoilage. The temperature is lowered to about 0 degrees Celsius with the help of ice to prevent putrefaction. Lowering of temperature prevents multiplication of bacteria and also reduces enzymatic action. Hence, large amount of crushed ice is used to lower the temperature of the fish by storing them in alternate layers of fish and ice. Freezing. This is more effective method and the temperature is lowered below 0 degrees Celsius by mixing salt with ice or by refrigeration. Freezing can be done in air or brine salt solution. Frozen fish often lose flavor and may become distasteful. Simple freezing results in denaturation of flesh due to the formation of ice crystals in the muscles and loss of flavor by leaching. Hence, the fish is subjected to glazing with water or by wrapping it in wax paper or cellophane. Deep freezing and freeze-drying. Deep freezing is done by rapid lowering of temperature to -40 degrees Fahrenheit. Deep freezing is accomplished by using a current of cool air or by brine freezing. This prevents denaturation and the flavor of the fish is retained. Freeze-drying is a modified process of deep freezing in which frozen fish is dried by direct sublimation of ice to water vapor without melting into liquid water. Sun-drying. Fish are first washed with clean water and are then dried in the sun to prevent growth of bacteria. For this, fish are spread on the sand or mats or hung on bamboo frame in the sun for 2 to 3 days. This is a simple and cheap method for preservation. Salting. Salt brings about dehydration of fish by osmosis and is a cheap and dependable method for preservation. Moreover, salt coagulates proteins and inactivates the enzymes. The fish is cleaned with water after capture, and enough salt is applied to it. The fish is rolled in salt and also covered with salt. After salting, drying is done in cool, shady place. Large fish are first gutted and salt is applied in the abdominal cavity. Brining. Instead of dry salt, brine of salt solution is used. For this, containers of suitable size or cement tanks are used. Pickling. Pickling is an easy method for preserving fish. Pickled fish must be stored in the refrigerator at no higher than 40 degrees Fahrenheit, and for best flavor, must be used within 4 to 6 weeks. Ingredients for pickled fish. Fish. Only fresh, high-quality fish. Water. Avoid hard water as it causes off-color and flavors. Vinegar. Use distilled. White vinegar with an acetic acid content of at least 5%. This percentage of acetic acid is needed to stop bacterial growth. Salt. Use high-grade, pure canning or pickling salt. It does not contain calcium or magnesium compounds, which may cause off-color and flavors in pickled fish. Smoking. Fish is first treated with brine to remove moisture and is then dried in smoking chambers. The smoking chamber is well insulated to retain heat. Fish are hanged on special structures, and the smoke produced by burning hard wood is let into the chamber through pipes. Density of the smoke, its temperature, and speed of circulation is controlled properly. Canning. Fish are cut into small pieces, washed and cleaned to remove blood and slime. They are treated with brine or pickled to give proper flavor and firmness. After cooking, pieces are packed in cans, which are sterilized with steam at high temperature so as to kill bacteria causing spoilage. Finally, cans are sealed and tested for any leakage before being dispatched to the market. Use of chemicals and radiation. Spoilage of fish can be prevented by using a number of chemicals, drugs, and preservatives. Several antibiotics as the aureomycin, tetramycin, and chloromycetin are used. Of these, aureomycin is most effective and improves keeping quality of the fish even at low concentration. The chemicals which are well-known preservatives are salicylic acid, sodium benzoate, sodium bisulfite, sodium nitrite, and sodium chloride. Of these, the nitrites of sodium and potassium are good preservatives for fish and inhibit bacterial growth. Exposure to low radiation of gamma rays kills all types of bacteria and prevents spoilage. Thanks for watching. Please subscribe my channel.